Okay, so what we're going to do is basically we're going to solve what's called a system of equations. So this may be familiar if you took Algebra 1 in the past, but if not, it could be new and it can get tricky. So as a general rule of thumb, the number of letters that you have that are different, so like I have an X and a Y, that's two different letters, that's the number of equations you would typically need to solve for those letters. So I have one equation here, and I have a second equation here. So I'm good. I have two equations for two different letters. So what we're going to do first is a process called elimination. And it's pretty self-explanatory in the title. We're going to eliminate a variable. So the first step is just what I call stacking the equations on top of each other. So we'll write 5x plus y equals 9. Now this is nice and in order for us. If it wasn't, we want to make sure that we line up our x's, our y's, and our numbers. So we're going to write 10x minus 7y equals negative 18. So again, if they didn't have this lined up nice and pretty for us, we would have to either add or subtract depending on what needs to move to another side so that we can get this set up in order. So I like to draw a little line underneath that symbolizes, hey, I'm going to do something. So what I want to do is I want to first pick which letter do I want to get rid of. And what we're end up going to be doing is we're going to add straight down. So if I were to add these right now, I would have 15x minus 6y equals negative 9. Well, I don't want that. I want one of the letters to go away so I can solve the equation. So you can either try to get rid of the x's or you can try to get rid of the y's. In order for two things to add to 0, one has to be positive and one has to be negative. Since the y's are already doing this for us, I see less work for myself, so I'm going to choose to eliminate the y's. So I'm going to choose to modify this equation because there's really a 1 in front of this y. So I just have to think, what do I need to multiply 1 by so I get 7? And the answer is 7. But because it's an equation, I can't just multiply 7 to the 1y. I have to do it to everything so it remains balanced. So I'm actually going to take this answer and I'm just going to rewrite it down here just to stay organized. So when I distribute the 7 in, I first get 35x. And I distribute again, and I get plus 7y. And I distribute one more time, and I get 63. So what I'm going to do is take this equation and bring it down underneath, again, so that they are stacked nice and neat on top of each other. So just kind of recopy our 10x minus 7y equals negative 18. Now I'm actually ready to do the math because I see two things that are going to cancel out when I add them together, and that is my 7y and my negative 7y. They actually cancel out. So what I'm left with is 35 plus 10, which makes 45x, and 63 plus negative 18, which is going to make just going to make 45. So when I go ahead and divide through and solve for x, I get x equals 1. Now that I have one of my answers, I don't need to do the elimination process again. I can just simply plug my answer into either equation over here on the left, and I'm going to solve for y. So again, it does not matter which equation you pick, either one will work. I like this equation because there's less numbers and there's no minus signs in it, so I'm going to choose to work with that one. Instead of x, I now know x is equal to 1. So I'm just going to plug that in. And do a little simplifying here. And if I subtract 5 from both sides, 5 minus 5 is 0. And I get y equals 4. So I'll just throw that in over here, that y equals 4. And so if I chose to do this in the other equation, I would have 10. Instead of x, I would choose to use 1 minus 7y equals negative 18. And again, I'm just going to simplify a little bit. And if I divide by negative 7 on both sides, I get y equals 4. So you can see that we got the same outcome no matter which equation we use. And that's the basics of elimination. So again, the important part is to try to make one equation, one of the variables, come out to the same number as the other variable. So I could choose to make 5 look like negative 10 because that would be opposite of this. I could choose to make 10 look like negative 5 if I wanted, but instead we chose to make 1y become 7y. The next process we have is called substitution. So you can either use elimination or substitution depending on what's involved in the problem. Either one will always work, but in some cases it's just more convenient to use one method over another. So if I chose to use substitution, what gives it a way to make me use substitution is there's no numbers in front of x or y. And we'll see in a minute why that's important. So what you have to do is choose which letter do I want to have by itself on one side. Now since my y is negative, I could just add it to the other side and I wouldn't have any negative signs to deal with. So I'm going to choose to do that route. But you could certainly move the x over and divide out the negative if that was something you prefer. So when I rewrite this, I get that x equals 11 plus y. If I would have had a number, let's say if I had a 3 in front of x, let's say I had 3x equals 11 plus y. I would not be done because I would have to divide out this 3 to every item in the problem. And the reason I don't want to do that is because now I have to work with y over 3, which is 1/3 y, and I have to work with 11/3, which they're not convenient fractions or decimals to work with. They make my life harder. So we're going to choose not. So in that case, I would choose not to use substitution because that's just going to make it uglier. Elimination would be the better option. So what I can do now is I can take my value for x, since this set is equal to x, and I can go ahead and substitute it in for x in the other equation. You can't substitute back into the equation you start with. It's going to be inconclusive. You'll end up getting something like 0 equals 0. So when I do that, I would have 2, and instead of x, I'm plugging in 11 plus y. And then I'm just going to finish up the equation. Now to pick a normal equation, I'm just going to solve for y. So we'll go through here and distribute. And then I want to combine my like terms, so I have 2 y's and 1 y. That's going to make us 3 y's. Subtract 22 from both sides. And when I divide by 3 on both sides, I get y equals -1. So just like with elimination, I'm going to go through and erase this. You can pick either equation. It does not matter. It will make no difference. And you just plug your answer back into one of the equations. So I'll choose to use our second equation here. It looks like it might be a little quicker. And instead of writing x minus y, I am substituting -1 in for y. And when I have a negative outside, it's really like saying -1. It's like saying x plus -1 times -1. So when I multiply those, it ends up being +1. And then I'm going to, of course, subtract 1 from both sides. So I get x equals 10. So the solution pair to this equation is 10 and -1. If I were to graph these two equations on the coordinate plane, if I graphed those two lines, let's just say they looked like that, this point is where they intersect. So it's the one and only time that those two lines will intersect. Now I could have substituted this way. I just chose not to because it looked like I would either have to do some dividing or I would have more numbers in the mix. But it works either way. Our last example, when you look at it, it looks kind of busy. So right away, I know, I think I want to use elimination. I don't want to use substitution because at some point I would either have to divide everything by 5, 2, 3, or -2 in this side. And since these numbers don't work with dividing by those, I know I would have to deal with fractions. So instead of having to deal with those fractions and make my life harder, I'm going to use elimination. 9 times out of 10, elimination is the better way to go because it's less work. So we're going to stack our equations. Draw a line. Now this one is a little bit more work than the previous one because there's no one step to make 2 look like 5 or 5 look like 2. And there's no one step to make 3 look like 2 or 2 look like 3. So in this case, I'm going to have to manipulate both equations. So what I need to think of, and let's say pick the x's, just because, actually no, I won't pick the x's, I think I'll pick the y's just to show this point. They're both positive, so one of these numbers is going to have to be a negative. That way I have different signs and they can add to 0. So I'm going to think of a number that both 3 and 2 multiply into, or I could just multiply 3 and 2 together. So I could multiply these by each other. So I can multiply this equation by -2 because I need the negative again, so this becomes a negative. And I'll multiply this equation by 3. Since I'm multiplying each number times itself, or the other number I should say, they're going to end up canceling out. But just again to reiterate that, let's say I chose to work with -2 and 5. I could just multiply, since the signs are already different, I don't need to worry about that. I would use 5 up here and 2 down here because they're opposite numbers. But I'm going to stick to my plan and we'll use -2 and 3. So we'll have to go through and distribute again. And I'm going to write my answer down here. So negative 2 times negative 2 is a positive 4x. Negative 2 times 3 is a negative 6y. Negative 2 times negative 19 is positive 38. And for the bottom, I would end up getting 15x plus 6y equals 114. Now I'm ready to add downwards, and you can see that negative 6 and positive 6 will cancel out to make 0. 15 and 4 make 19 x's. 38 and 114 are going to make 152. And when I divide by 19 on both sides, I get x equals 8. So this elimination problem is a little bit harder than the other elimination problem because I had to multiply both equations, and sometimes that'll happen. Now that I've got my x, I am allowed to substitute it into either equation and get my y value. So let's just pick this one because I don't see any negative symbols in it. Might be easier to work with. So I have 5. Instead of x, we're going to put in 8 plus 2y equals 38. And I'll go through and simplify. So I get 2y equals negative 2. Therefore, y must be negative 1. And so my solution pair would be 8, negative 1. Now again, if you had chosen to use substitution for this, it will work as long as you do the math correctly, but you're going to have to deal with adding and subtracting fractions to both sides, and that can get a little messy. So multiplying and eliminating is definitely an easier way to go.